In this video, we're going to take a look at covalent bonding, and this is different than ionic bonding. Ionic bonding happened between a metal and a nonmetal. Covalent bonds are going to occur between two atoms, and instead of transferring electrons, we're going to share electrons. Okay, so we're not going to have any charged pieces. No charged ions here. Okay? So when a covalent bond forms, these electrons are shared, and that happens between two nonmetals. And if you think about that, why is this going to happen between two nonmetals? Well, if we look at a sodium ion, or sodium atom, sorry, it's got one valence electron, and another sodium ion has one valence electron. If they shared those two, like doing this, so they had, neither one of these guys is happy. Neither one of them has 8 valence electrons. But if you were to consider something like oxygen, 1, 2, 3, 4, 5, 6, sharing with another oxygen, 1, 2, 3, 4, 5, 6. These two electrons get shared, so this oxygen atom thinks it has them, and these two electrons get shared, so this oxygen thinks they have them, but so does this one. So it's got 1, 2, 3, 4, 5, 6, 7, 8. By sharing, both of these atoms were able to come up to 8 total valence electrons, even though neither one of them really gained any. Those electrons just get to spend time with both atoms. Okay, so it forms between two nonmetals because they're already close to having 8. Now, a molecule is a covalently bonded group of atoms. So ionic compounds have ionic bonds. Molecules have covalent bonds. And there are always going to be nonmetals in this. So water is a molecule. It's two hydrogens bonded to an oxygen atom. Glucose is a molecule. It's got carbon, hydrogen, and oxygen bonded together. Hydrogen right here is a molecule, but you'll notice this one's not a compound. H2 is hydrogen, the element. It only contains one atom. That's true of some molecules. There are 7 diatomic molecules that are not compounds. Di means 2, diatomic, so 2 atoms. These are not compounds. This is bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. To remember that, that's Brinkelhoff. These always come in pairs if they're not in compounds. These are the diatomic molecules. And when we name these, we call them bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine, okay, because they are not compounds. They are just those elements. But you should be aware, if you have bromine in a compound or bromine in a reaction, it's Br2. If oxygen's in a reaction, it's O2. Now, if these are in compounds, that all changes because they're form different bonds. Now, molecules actually are named a little bit different than ions. Ions just, we started with the metal and we had the nonmetal. So if I had Al2O3, we just said, all right, the metal comes first, aluminum, the ending of oxygen changes to IDE, so this is aluminum oxide. And we would have to actually go figure out the charge of the ions to figure out the compound, or the formula for the compound Al2O3. Molecules actually give us a little bit of a way to cheat. When we name molecules with 2 different atoms, we use prefixes to tell how many atoms. Okay? So you name the first element beginning with the appropriate prefix. I'll show you what that means in a minute. There is this caveat here. Do not use mono if it's only one of the first element. So for instance, CO2, there's only one carbon on here, so it's not going to be monocarbon, it's just going to be carbon. Now, you name the second element beginning with the appropriate prefix, and you change the ending to IDE. Okay, so CO2, like I said here, that's carbon, and then there's a prefix for 2, it's di. So you're going to name this carbon dioxide. So this is a list of all the prefixes: mono, di, tri, tetra, penta, hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. Okay? And you can actually go all the way up to 20. I probably won't very often go much past 6. But let's take a look at, say, H2O. The first element is hydrogen, and there's 2 of them. So according to my first rule, I'm going to name the first element beginning with the appropriate prefix. So dihydrogen. Then I have oxygen, appropriate prefix, so mono, and then oxygen, except that I'm going to change the ending to IDE. So instead of monoxygen, I'm going to have monoxide. Okay? Like I was saying up above with CO2, that's carbon, and the prefix is mono, but since there's only one, I don't use it, so it's carbon. Then there's two oxygens here, so that's carbon dioxide. Okay? Methane has the chemical formula CH4, so that would be carbon tetra, because there's 4, and then hydrogen, but remember, change that ending to IDE, carbon tetrahydride. Okay? So you can actually decode the name of a molecule to figure out what it is. If I were to say silicon dioxide, you could look at that and you could say, okay, well, silicon is Si, di means 2, oxygen or oxide is oxygen, so SiO2. There's the chemical formula for silicon dioxide. If you see prefixes in a chemical name, then you know that it's a molecule. That means it's got covalent bonds in it.